Now let's work on this function here to determine the relationship between A and B. So f is a probability density function. Okay, in this case, we will have to check two things. First, we need to show that f of t is bigger than 0 for all t's in R. Second, we need to prove that the integral between minus infinity and plus infinity is 1. So to find the relationship between A and B, we check these conditions here. Our function is defined by only when t is positive. So it's a e to minus bt, and we have a and b both positive. Okay, this gives us the first condition. Okay, we don't need to do any work here. Okay, since a and b are both positive, therefore e to minus bt is bigger than 0. And a is positive. When we multiply, we still have this condition, therefore f of t is bigger than 0. Okay, next we're gonna integrate. Okay, here to check the second condition, we have the integral between minus infinity and plus infinity. So we're gonna integrate between minus infinity and 0 plus the integral between 0 and plus infinity f of t dt. Here this is 0 because f is 0 on this interval, and therefore we have only the integral between 0 and infinity. And using the definition of the improper integral, we have here the limit as x goes to infinity of this integral, a e to minus b dt. Okay, here a is a constant. We take it outside, and it's easy to see here that this one is just minus 1 over b e to minus b t between 0 and x. Okay, now we evaluate. So we have minus, let me put the minus outside here. So minus a over b, the limit as x goes to infinity of, I took the minus 1 over b outside, and therefore I have e to minus bx minus when t is 0, I have only 1. Okay, here as the limit goes to infinity, this one will be 0, and this one is minus 1, therefore I have a over b. And now this integral has to be 1, therefore this is 1. And therefore the relationship between a and b is that a is equal to b. Okay, so to have this one as a probability density function, we need to have a is equal to b. Therefore, we define this one to be a probability density function as a e to minus at, when t is bigger than 0 and 0 otherwise. Okay, in this case, if a is positive, this is a probability density function. Now we are sure. The relationship is that a is equal to b. It's coming from this condition and this integral here. Okay, and this shows that we can write an exponential distribution in this manner. Okay, it's defined only when t is positive. Okay, and it can be written in this manner. Okay, this is an exponential distribution. Okay, density function in this case, and we can use it to model time-dependent phenomenon. We will see. We're going to compute the mean and maybe the standard deviation if we have time. Okay, thank you very much.